Let's take a look at this next one. A couple has 3 children. Determine the probability of the couple having all 3 boys. So same idea all over again. So we want to find the probability of all 3 being boys. So the first thing that we'd want to look at is what's the probability of the first child being a boy? Well, you've got 2 options, right? You've got a boy or a girl. And only one of those 2 is a boy. Now let's look at the next child. You still have 2 choices, a boy or a girl. And still only one of them's a boy. Now for my third child, still the same thing. There's still 2 choices, a boy or a girl, and only one of those is a boy. So going straight across, multiplying these fractions will give us 1 times 1 times 1 on the top, which is 1. And then 2 times 2 times 2 on the bottom is 8. So your chances of all 3 of your children being boys is 1 out of 8, which is 0.125, or about 12.5%. Continuing along, find the probability that a person spent less than $100 and had a purebred. So let's take a look. How many people did spend less than $100? Well, that spent less than $100, but we want to make sure something else is also true, and that they had a purebred. Well, there's only a small group of people that fit that category. There is 18 people who spent less than $100 and had a purebred. There's 18 out of our total, which has not changed, is still at the bottom right-hand corner, out of our total, which is 90. So we've got 18 out of 90, which is 0.2, or 20%. Let's take a look at another one. Find the probability that a person had a mixed breed and spent $100 or more. So in this one, we're looking for they had a mixed breed and spent $100 or more. So how many people did have a mixed breed and spent $100 or more? Our overlap there is the 15 that had the mixed breed and spent $100 or more. Out of, still the total is 90, so 15 out of 90. And again, I'm not concerned about reducing these. What I'm worried about is turning them into a decimal, so I have a probability, which is 0.167. So that's about 16.7%. Let's take a look at C. Find the probability that a person spent less than $100 given that the dog was a mixed breed. The wording on this one is much, much different, and so we have to be very careful. So they spent less than $100 given that the dog was a mixed breed. So right off the bat, when we look at this, given that the dog was a mixed breed, it means we are only looking at people who have a mixed breed dog. That is the only part of this chart that we should be looking at. Kind of think of it as we have tunnel vision. This is the only part of the chart that we care about, is the mixed breed dogs. Now, of those mixed breeds, what we're looking for is how many spent less than $100. Well, of all of those mixed breeds, how many people spent less than $100 this year? 21. So we still have our 21 on the top. The difference is we have tunnel vision. We said given that we're looking at a mixed breed dog. That means I'm not looking at all dogs, only mixed breeds. So my total isn't everybody. It's not the 90 anymore. It's first time we're going to do this, is a total of 36. We changed our conditions. Remember this, given that means I'm not looking at the same conditions. I'm only looking at mixed breed dogs. So there's only 36 of those. So I've got my 21 of my mixed breeds that spent less than $100 out of the total mixed breeds, which is the 36, getting me a probability when I divide this out of 0.583. Okay, let's try another one. Let's take a look at D. In D, find the probability that a person the dog, that a person has a dog that was a mixed breed, given that they spent less than $100. So again, I'm going to start with actually the last part first here, is given that they spent less than $100. So I'm only getting tunnel vision and only looking at people that spent less than $100, which means my total, or my tunnel vision total here, is that I'm only looking at the people who spent less than $100, which there's only a total of 40 of those people. Now, of those 40 people that spent less than $100, what I care about is how many of those were a mixed breed. Well, how many of the people who spent less than $100 were a mixed breed? Well, that's that 21 again. So we're getting the same top number, the 21. The difference is I'm only tunnel visioning out to looking at those who spent less than $100 or less than $100, which was that there's only 40 of those. So just like before, this was a conditional probability where I'm limiting who I'm looking at. I'm only looking at people who spent less than $100. So I've got the 21 of those that were mixed breeds out of the total who spent less than $100, which is the 40, which gives me a probability of 0.525. Last one here is actually not me doing one thing. It's not a conditional probability, at least to start with. It's just saying find the probability of selecting two people that spent $100 or more. Okay, so this means that the first person should be $100 or more, and the second person should be $100 or more as well. Now, they didn't tell us this in this one, but they really should. So we're going to assume that this is without replacement, because they didn't say anything one way or the other. So if they don't say anything one way or the other, assume you're not replacing. So let's talk about this. We're talking about how many people spent $100 or more. Well, for your first person, how many spent $100 or more? That is a total of, we're just talking about normal people, not changing conditions, a total of 50 out of the 90. That's for your first person. However, if we do this without replacement, now your probability of your second person you're selecting spending $100 or more has now gone down. If you're doing it without replacement, we'd be down to 49 out of 89. And we'd be multiplying. So that would get you the 50 times 49 on the top, which is 2,450 out of, well, the 90 times the 89 on the bottom would get us 8,010. So the 2,450 divided by the 8,010 gets us 0.31 or 31%. And again, I just had to throw in that this was without replacement. They should be telling me if they really want me to do a problem like this.